Hello, hello. This is section 8.6, and today we're talking about quotients with radicals. This is one of my favorite sections. I really like to rationalize denominators. It's kind of a fun process, and most students, if you can multiply radicals, do really well with this. Okay? So today what we're going to do is we're going to rewrite fractions with a radical sign in its denominator as a fraction with a rational denominator. So basically, what we're going to do is we're going to take square roots out of the downstairs of fractions today. And here's a journal choice for you. What is a conjugate and when are they used? Let's talk for a minute about mathematical manners. It is not mathematically polite to leave a radical or an imaginary number in the denominator of fraction. We talked about the imaginary numbers in the denominator of fractions first semester. We just don't do it. We need to get it out of there. The same is true with radicals. So we're trying to get any radical, not just square roots, but we deal with square roots a lot, out from underneath of the fraction. The verb that we say when we do this is called rationalizing the denominator. You will hear this phrase, rationalize the denominator, throughout the rest of your mathematical career. And basically the process is we're going to rewrite the fraction into an equivalent form, so it's still going to be equal to the original, but it's going to look a lot nicer. It's not going to have a radical in the downstairs, it's just going to have an integer value. Okay? You can have radicals in the numerator, and in fact, if there was one in the denominator, chances are very, very good there will be one in the numerator, and that is quite all right. Okay, so here's our practice. We're going to rewrite 26 over the square root of 13 by rationalizing the denominator. Basically, and we have done this before when we were dealing with imaginaries, we are going to rewrite this to something that is equal to what we started with. The only way we can change the appearance of this and keep it equal to what we started with is by multiplying by a fancy version of 1. So we're going to multiply this by 1. The trick is picking the correct form of the number 1 so that we can change the appearance. And what's nice about square roots is if you take a square root of a number, like the square root of 2, times itself, the square root of 2, that gives us the square root of 4, which is 2. How come? That's 2 to the 1/2 times 2 to the 1/2. We add our exponents, and that's 2 to the 1st, which is 2. So that's the nice thing about square roots, okay? So what we can do is multiply the top and bottom by the square root of 13 and some over square root of 13 because that is equal to 1. And some nice things will happen. Square root of 13 times square root of 13 is just 13. Still have the 26. When I multiply that by the square root of 13, I just get 26 root 13. There's nothing I can combine here. I can simplify though because 26 divided by 13 is 2. I'm still left with the square root of 13. So my answer is 2 root 13. This is equal to this. They look very different, yes, but I know they are equal because the only thing I did was multiply by 1. And if I type in my calculator, and this is an important skill for when you guys take the ACT, if I type 26 divided by the square root of 13 in my calculator, I get a nasty decimal. If I take, I should write that down. If I take 2 root 13 and I type that in my calculator, I will get the same nasty decimal. That will tell me that they are equal. Okay, so it's an easy way to check. Rationalizing. To rationalize the denominator, what we did and what we just finished doing was we multiply the top and bottom of the fraction by the radical. Why do we multiply both the top and bottom? We just said that because you can't change the fraction, so we're multiplying by 1. This is an example and was supposed to fit in there, but when I transferred it over to a flip chart, it didn't work out very nicely. This one is a little special because I have square root of 45, which can be broken down to something a little bit nicer. So you have options. You can simplify first, then rationalize. I don't want black. Or you can, what did I say first? Simplify. Rationalize first and then simplify. Usually kids will, if they see it right away, will go ahead and simplify it. Otherwise, they will just I mean, I guess I just, whatever I see first, but some kids like to do the same thing every time. It doesn't matter. I'm going to show you both ways here. 5 over square root of 45x. I'm going to simplify first to begin with. Okay, I'm going to change square root of 45 to something that can break down. 9 is a perfect square, so 9 times 5x. Square root of 9, I could take that out. 5 over 3 square root of 5x. That 3 can stay downstairs, and that's not a problem. It is not doing any harm in the denominator. What's not allowed is a square root of 5x. So I need to get rid of it. I will do that by rationalizing and multiplying the top and bottom by square root of 5x. That is a completely legal move because that just equals 1. What am I left with? Well, I'm left with 5 square root of 5x on the top. And on bottom, when I multiply square root of 5x times square root of 5x, I'm left with 3 times 5x. Okay, you have more options here. If you see right away that you could simplify the 5's, that will make your life easier. Otherwise, if you would have multiplied and got 15x, then you can see that they have 5 in common. It's easier if you go right away, though. So let's go with square root of 5x all over 3x. Almost lost it. Almost lost my x there because those 5's are going to simplify out to 1. How about these x's? Can they cancel? No, they cannot cancel because that is x to the 1/2 power and that is x to the 1st power. Okay, I could subtract them, but that gives me negative 1/2, which is right to where I started, which would put it in the downstairs, which is what we were trying to avoid to begin with. Okay, what if I did not simplify first? Okay, let's say I just jump right into rationalizing. You will still get the same answer. I'm going to multiply the top and bottom by the square root of 45x over square root of 45x. I now get 5 square root of 45x all over 45x. I can simplify the fraction here, and then I will also have to simplify the radical. So let's go ahead and do that. Square root of, I'm doing two things at once here, 9 times 5x. That's breaking down the radical. The 5 and the 45 are going to simplify out to 9x down below. Do not simplify those 9x's because that's not what I have. Square root of 9 is 3 square root of 5x all over 9x. Now simplify the 3's. Square root of 5x all over 3x. Okay, so really it saved me simplifying steps to simplify it right off the get-go because I had more simplifying it seemed to do whenever I was avoiding it to begin with. So you will have to simplify no matter what. It just depends on when you do it. Okay. Let's clear annotations. Let's move this guy. Okay. What if we have a fraction that has a sum in the denominator? Something like this. How do I get rid of the radical here? Okay. Well, here it is again. We can't just multiply the top and bottom by square root of 5, and I want to show you why. If I multiply the top and bottom by the square root of 5 over square root of 5, that itself is legal because I'm not changing it. It just equals 1. But what I'm going to get is 2 square root of 5 over, this is a quantity, so I would have to distribute 3 root 5 minus 5 because I would double distribute here. And what do I get? Can't simplify any of that out because there's still a radical down there. It does not help me. So I can't just do that. What other things might we do? Well, here's what we're going to do, and this is what's going to get you the right answer. You need to multiply the top and bottom by the conjugate. Do you remember this word from imaginary numbers? Remember we had 3 plus I in chapter 6, and the conjugate was not the opposite. It was 3 minus I, and that was a very nice combination because when we double distribute, the i's cancel out, and you're left with a 9 minus I squared, which was nice because it was a 9 plus 1, which was 10. And all of a sudden, I don't have an I down below. The same thing is going to be true when you're dealing with radicals. What is the conjugate of a plus square root of b? It's a minus square root of b. You will have to double distribute or FOIL. Some of you like to say FOIL. And when you do that, those radicals will cancel out and it will rationalize the denominator. Okay, so let's look at this one. What is the conjugate? Well, it's 3 plus square root of 5. So we're going to multiply the top and bottom by this more complex form of 1. 3 plus square root of 5 over 3 plus square root of 5. We're going to distribute the top, and I get 6 plus 2 square root of 5. And on the bottom, I get 3 times 3 is 9, plus 3 root 5 minus 3 root 5. The O and the I of FOIL, the outer and the inner and the double distributing, cancels out. And I'm left with minus square root of 5 times square root of 5 is just 5. So I get 6 plus 2 square root of 5 all over 4. Look at this. I have 2's in common here and 2's in common here, so I do need to simplify further. 3 plus square root of 5 over 2. And this is a nicer form for us because there's not a radical in the denominator, so the denominator was rationalized, which is what we are trying to do to begin with. Those two fractions are equivalent. Okay, so we got more practice here. I wonder how much I have. Oh, I have lots of practice. Okay, so let's just do a few on these odds, and you guys can stop whenever you need to. These are easier to do. I'm just getting rid of that radical, so I'm going to multiply the top and bottom by the square root of 5. And I get square root of 5 over 5. I'm actually going to go like this because that way my stuff won't run into each other if I take two lines. Okay, so I'm not doing this one. I'm going to do 4. On this one, I'm going to multiply the top and bottom by the square root of 10 over square root of 10. I will get 5 square root of 10 over 2 times 10. You can simplify the 5's first, or you can multiply first, whatever you see. I am going to simplify this 5 with the 10. That will leave me the 2 down below, so I get the square root of 10 times 4. Is the square root of 10 okay? Can that be broken down further? No, it can't, because a perfect square does not go into it. Yes, I could break down 10 to 5 times 2, but that does not help me. Nothing can be pulled out from there, so that doesn't help. Okay, we're going to skip 3, move on to 5. To get rid of that radical in the denominator, I'm going to multiply the top and bottom by square root of x over square root of x, and I'm left with 4 root x over x. Skip 6, go on to 8. You can simplify this radical, so we could do that first if you'd like. 3e over, I'm going to change this to an even exponent because it's a square root, so e to the 6e. The square root of e to the 6 is e to the 3rd. And I'm still left with square root of e down below. You could simplify here if you'd like. So that's 3 over e squared, square root of e. Now I will rationalize by multiplying the top and the bottom by square root of e. And I get, I'm coming down below here, 3 square root of e all over e squared times e, which is e to the 3rd. Okay, skip 7, look at 9. We can simplify here. We can simplify the n if you'd like. I don't think I'm going to this time because the 6 isn't going to change. So this time let's just look at it by going straight to the rationalization. Square root of 6n to the 5th over square root of 6n to the 5th. You guys can decide which way you like better. 8n square root of 6n to the 4th n all over 6n to the 5th. Lots of simplifying to do here. The 8 and the 6 leave me with a 4 and a 3, right? N and the end of the 5th leaves me with the end of the 4th down below. So that's all changed up here. Square root of 6. The square root of n to the 4th can come out. That leaves me an n squared here, square root of 6n. Still more simplifying with the n squareds, and I'm left with 4 over 3, n squared over n to the 4th, leaves the n squared down below, square root of 6n. Yuck. Well, that's what we got. Okay. This is just practice with the double distributing, multiplying by conjugates. Do the work by hand. Let's just do these bottom two, if you will. 3 times 3 is 9. Plus 3 root 5 minus 3 root 5 cancels out. Minus 5, and that it gives us 4. I'll do the top now. I lied. D times D is D squared. Minus 2 root D plus 2 root D. Those cancel. Minus 2, and it leaves me with D squared minus 2. Alright, on the back it gets a little more complicated. Multiply here by the conjugate, which is 3 minus square root of 2 over 3 minus square root of 2. And I get 21 minus 7 root 2 over 3 times 3 is 9. Plus 3 root 2 minus 3 root 2 cancels out. Minus 2, which is 7. 21 minus 7 root 2. Oh, that's not what I wanted to write. All over 7. They all have a 7 in common, so I'm left with 3 minus square root of 2. Okay, let's look at 18. I'm going to multiply by the conjugate again. 6 plus square root of r over 6 plus square root of r. On the top, I'm left with 24 plus 4 root r. On the bottom, I get 36. Plus 6 root r minus 6 root r cancels out. Minus r. And that's as good as it gets. Yes, these have a 2 in common, but when you do that, you have to look at the whole denominator with each piece. And they don't all have anything in common, so this is as good as it gets, guys. 19, let's multiply the top and bottom by its conjugate, which is 7 minus square root of 2 over 7 minus square root of 2. T, that probably is annoying to you, sorry. 7t minus t root t. Kind of looks weird, doesn't it? But that's what we have. All over 49. Minus 7 root t plus 7 root t cancels out, and I'm left with minus t. Okay, is there anything I can simplify? Here's no, and here's no. That's as good as it gets. 22. Let's multiply the top and bottom by 27 plus 18 root 2. 27 plus 18 root 2. It's kind of gross. Okay, so I get 54 plus 36 root 2 all over 27. These cancel. What is it? I don't know what 27 times 18 is, but I don't really need to know. I do need to know what 18 times 18 is. Okay, I got 18. When I do this, 27 times... Oh, why did I write 27? Good thing I caught that. 27 times 27 is what I need to do first. Ew, 729. Now, the O and the I will cancel, and I'm left with minus 18 times 18 is 324. So it's going to be 324 for the 18s, but then that's going to be times 2. So I'm going down below now. I get 54 plus 36 root 2 on the top over 729 minus 648 on the bottom, which is 81. 9's in common, right? Yeah. So all these have a 9 in common. 54 divided by 9 is 6 plus 4 root 2 over 9, I think. That's what I got. I don't know if I did that right. You guys will have to check my math on that one. Okay? And on these down below here, what they're wanting you to do is write the expression in radical form with a rational denominator. So first write it with radicals, then change it up to one with a rational denominator if necessary. So 5 to the 3 halves. That's a square root of 5 to the third, which is 125. This is times a to the negative 1/2, which is 1 over square root of a. Okay, so I wish I could. Here's what I'm going to do. Right over here. Oops. This video is probably super long by now, but I'm having so much fun. Okay, so I have square root of 125 over, what did I say, square root of a. Okay, we can multiply top and bottom by square root of a over square root of a. So I get the square root of 125a, which is 25 times 5a all over a. Square root of 25 is 5, so I get 5 square root 5a over a. Okay, that's how you're going to do those bottoms. First write it with radicals, then go ahead and simplify. I think that's it, and I hope you enjoyed it. Rationalizing is fun because radicals are radical, yada, yada, yada. Okay, goodbye.